Pico technology products have some really interesting applications, and today we've got an absolutely brilliant one. Hello, we are at MASPLAS, and today we're getting involved with the development process of a prototype injection molding process. So we're going to be using the TC-08 to do some temperature testing of the outside of the mold. So let's dive right in. Injection molding is the process of creating a mold conventionally made out of metal and forcing melted plastic into the mold, allowing it to cool quickly into a solid piece of plastic. It's a process done all over the world for high volume manufacturing. But what makes Ash's particular application different?
So at MASPLAS Moldings, we injection mold subcontract parts. It uses a tool with a cavity on the inside, and this goes into a machine that heats plastic up, forces it in, and that creates a plastic part of the shape of this cavity. A part like this on the small machine will cost like a few hundreds, maybe £1,000 to make. So when you're starting in that prototyping stage or a low kind of volume molding, it makes the barrier for entry financially really high. Another example is for this, the tooling costs £5,000. So you imagine trying to test this concept without a 3D printer, you've got to dive straight in at that high cost. So what we are doing is making a standardized insert inside one of these metal bolsters, which means you can just 3D print out of resin an insert that will bolt in, that will have the negative cavity, and allow you to print 10, 20, however many parts you want, and it'll be a functioning part.
Injection molding may seem simple, but because of the temperatures and pressures it uses, the molds have to withstand these massive changes. It's important to monitor these changes, which is a perfect application for the Pico technology TC-08 temperature logger. So here's Ash to tell us a plan.
So I asked Pico to come down today because I need to monitor numerous aspects of this moulding. So there are some concerns about cooling rates, which is related to the strength of the plastic. It needs to crystallize properly inside, so it needs to cool quickly. Resin is actually quite a high insulator, so it's hard to get the heat out when you're moulding. So not only are we doing tensile strength testing at break point on these plastics to make sure they match up with steel tool moulding, but we're also keeping an eye on the temperatures. So we're using the TC-08 temperature logger to put probes on the back of the actual resin mould, as well as the sprue bush, this metal insert that goes into the mould. Because obviously these tool parts are getting very hot. They're injecting at 160 to 210, depending on the plastic, degrees Celsius.
To set this up, we used 3 different K-type PTFE insulated thermocouples. As mentioned by Ash, we taped one to the mould casing for the ambient mould temperature, a second to the sprue bush, which is the entrance point for the molten plastic, and the third we used as an ambient temperature. Ash then performed consecutive stress tests on the resin mould using the TC-08 to analyse the heating and cooling rate of each moulded piece and seeing the maximum saturated temperature of the mould at full speed operation. We are also looking out for the maximum failure temperature if the mould were to fail in one of these tests. The first material to test was the lower melting point plastic that melts at 160 degrees, which is within the maximum temperature specification for the resin mould material. After around 10 runs of the moulding process, all 10 mould pieces were successful with no damage to the part, which is a great success. During the second round of moulding, a higher temperature plastic which melts at 190 degrees was used. The plastic was well over the maximum temperature limit of the resin material. After a few moulds, the test pieces started to show signs of under extruding, meaning there was a failure in the mould. Unfortunately, there was a small crack in the mould which, due to the high pressure, was forcing plastic into the cavity, causing an under-extruding failure. Using the TC-08, we can verify the maximum temperature of the mould during the process to do further investigation with the improved mould and the same temperature threshold. Here's Ash's thoughts on the results.
On paper, the resin moulds are only good for like 50, 100 degrees Celsius, unless you get into really expensive resins. Which at first I thought was a guaranteed failure trying this, but they've actually held up for numerous moulds so far. So
thanks again to Ash and MASPLAS for inviting us to aid in this innovative injection moulding process. If you would like to see more applications of Pico Technology products, like and subscribe to this YouTube channel. And if you're interested in using the TC-08 in your own application, click the link in the description below to own your own TC-08.